Good afternoon, class. Welcome to the fifth session of DT Studio lecture on database management systems. Myself, Dr.Vijay.H.Kalmani, Principal of Jain Polytechnic, Belgaum. Well, dear students, in my previous fourth session, that is the previous class, we have started with Unit 2, that is data modeling using the entity relationship ER model. We have seen in the previous class overview of a database design, and also we did touch upon example of a database application, that is a company database. So just to have a quick recap of yesterday's slides. Well, I'll not be sharing my slides. I'll be just orally explaining you. Yesterday, in our first class of the Unit 2, we did see that there are two main activities in the database design process. The first activity is the database design, and the second one is the application design. And as I said, in this chapter on database design, we focus on to design the conceptual schema for a database application. So application design focuses on the programs and interfaces that are accessible or that access the database. Well, if you remember yesterday's diagram of a database design process, it was a simple diagram which illustrated the main phase of the database design. We had the requirements collection and analysis. We had the conceptual design. Then we had the logical design, that is data modeling mapping. And then we had the physical design. So in the first step in that diagram, it was shown requirement collection and analysis. So during this requirement collection and analysis, the database designers interview prospective database users to understand and document their data requirements. So these requirements should be specified in as detailed and complete a form as possible, in a complete form. So in parallel with specifying the data requirements, it is useful to specify the known functional requirements of the application. These consist of user-defined operations or transactions that will be applied to the database, including both during the retrievals, that is data retrievals and data updation. Well, once the requirements have been collected and analyzed, the next step was to create a conceptual schema for the database using a high-level conceptual data model. So this step was called as the conceptual design. If you just remember, we had the requirements collection and analysis at the top, then the conceptual design in the second layer. Parallelly with the requirement collection analysis, we had the functional requirements also. So the conceptual schema is a concise description of the data requirements of the users, and it includes detailed description, you can say, of the entity types, relationships, and the constraints. So these are expressed using concepts provided by the high-level data model. In the next step in the database design is the actual implementation of the database using the commercial DBMS. So commercial DBMSs use an implementation of data models such as the relational or the object oriented database model. So the conceptual schema is transformed from the high level data model into the implementation data model. And this step was called as the logic design or data model mapping. That is the third step. And the fourth step, that is the last step, we had the physical design phase, during which the internal storage structure, file organization, indexes, access paths, and physical design parameters for the data files are to be specified. Well, we also did see an example of a company database. So yesterday, I did not include that figure. Today, I would like to share it and explain you once again in quickly about the company database. So I hope you are all able to see example. Here is a company database. So in this section, we describe the database application called company, which serves to illustrate the basic ER model concepts and their use in schema design. So the company database keeps track of a company's employees. So company employees here. Company employee, departments, and projects. Okay. Suppose that after the requirement collection and analysis phase, the database designer provide the following description of the mini world, the part of the company that will be represented in the database. So the company is organized into departments, and each department has a unique name, number, and particular employee who manages the department. So we keep track of the start date when the employee began managing the department. So a department may have several locations. So department may have several locations. So department also is managing the start date also. So a department controls a number of projects, each of which has a unique name, a unique number, and a single location. So the department, it controls, we have shown here. So it controls projects, each of which has a unique name, unique number, and a single location. So we store each employee's name, social security number. So there is name, social security number, birth date, address, salary, sex or gender, etc. So an employee is assigned to one department but may work on several projects which are not necessarily controlled by the same department. So we keep track of the current direct supervisor of each employee who is another employee. So an employee, he works for some department, and department has the department employee can work on different projects. So we want to keep track of dependents also now. So dependents of the employees. So you can see here the dependents is there. So we keep track of the employee dependents like their spouse, parents, etc. So there we have attributes such as name, sex, birth date, relationship with the dependent, whether the dependent is spouse or mother or father, brother, whatever it is. So the next we see are some of the definitions, like what is an entity, what are attributes. So when we say an entity, it is nothing but it's specific. It's an basic object of that ER model, okay, which is a thing in the real world, or we call it as the mini world with an independent existence. So entities, they are specific objects. For example, employee is an entity. Employee becomes here an entity. Okay. Well, so entity, for example, it may be a particular person, a car, a house, or employee, as I showed you in this example. Or it may also, for instance, be a company, a job, or a university course that you are going to take up. So each entity has attributes. Basically, these attributes, they define the particular properties of the entities. So attributes are properties used to describe an entity. So here employee is an entity and its attributes are name, social security number, address, sex, and excuse me, birth date. Okay. So a particular entity will have value for each of its attributes. So here we say name is John Smith. Social security number is 123456789. His address is 731 Fondren, Houston, Texas. And its gender is male and birth date is 9th of January 1955. These are the values. So all attributes have values. So each attribute has a value set or a data type associated with it. For example, integer, string, subs range, enumerated data type, etc. So the attribute values that describe each entity becomes a major part of the data stored in the database. Well, there are several types of attributes. For example, a simple attribute. Now, attributes that are not divisible, are called simple or atomic attributes. This is also called as atomic. Here, each entity has a single atomic value for the attribute. For example, social security number or sex. So here you have single attribute, atomic value for these attributes. Sex may be either male or female. Social security number, you have some value, say a 10 number. For example, our Aadhaar card number. Excuse me. Now, what are these composite attributes? Now, these composite attributes, again, you can divide it into smaller subparts, which represent more basic attributes with independent meanings. For example, here the address. the address attribute of the employee is shown. Now in this address of the employee, you can see, I think it's better I show you this composite attribute hierarchy. So here you can subdivide further. So address has street address, city, state, and zip code or pin code, what you say. So the street address may be further divided into street number, street name, and apartment number. It may have uh, further sub attributes. So composite attributes can form a hierarchy of attributes. Okay. Now, if the composite attribute is referenced only as a whole, there is no need to subdivide it into component into component attributes. For example, if there is no need to refer to the individual component of an address, for example, pin code, street, and so on. Okay, that is zip. Pin code is nothing but zip. Then the whole address can be designated as a simple attribute. Acha. Then another type of attributes are nothing but your single valued or multi-valued attributes. Well, here I have defined multi-valued. Before I go to the multi-valued, I'll just would like to wrap up with the single value. See, most attributes have a single value for a particular entity. Such attributes are called single value. For example, age is a single valued attribute of a person. Right? You can have age as a single value is there, which may represent your number of years of a person. Okay. So in some cases, an attribute can have a set of values for the same entity. Such attributes are nothing but multi-valued attributes. So an entity which have multiple values for that attribute. So again here, for example, the colors, okay, the color attribute of a car may be restricted to have between 1 and 3 values. If we assume that a car have 3 colors at most, okay, or example, the previous degree of a student, okay. So in general, composite and multi-valued attributes may be nested arbitrarily to any number of levels. For example, previous degree of a student is a composite multi-valued attribute denoted by, see, the previous degrees, what sub-attributes it can have? College, year, degree, and the field of his study. So multiple previous degree values can exist. So each has 4 subcomponent attributes, that is college, year, degree, and field. Well, so an entity types and key attributes. What is an entity type? An entity type defines a collection or a set of entities that have same attributes. So each entity type in the database is described by its name and attributes. Okay. So an entity type describes the schema or intention for a set of entities that share the same structure. For example, the entity type employee and project. So an attribute of an entity type for which entity, each entity must have a unique value is called key attribute of the entity type. For example, social security number of an employee. So an attribute, a key attribute may be composite. So vehicle tag number is a key of the car entity type with components such as number and state. So when you see a vehicle tag number, you have a number. Say it's in Karnataka, it starts with KA, and if it is a Bangalore, it starts with 01. If it is Belgaum, it is 22, right? So K20 indicates Karnataka, and there is a number also, the state. First is the state, and then you have the number, say Z1658. So that is a number. So an entity type may have more than one key. So car entity type may have two keys. That is vehicle identification. In West, it is popularly called as VIN, and vehicle tag number, that is number and state. Again, in Western country, it is called as AKA license plate number. So each key is underlined. You can see here, we have underlined the each key here. Well, see the collection of all these entities of a particular entity type in the database at any point in time is called as a entity set, and it is usually referred to using the same name as the entity type. So the collection of entities of a particular entity type is grouped into an entity set, which is also called as extension of the entity type. For example, take employee. It refers both to type of entity as well as the current set of all employee entities in the database. Well, in ER diagram, an entity type is displayed in a rectangular box. So attribute names are enclosed in ovals and are attached to their entity type by straight lines. So the entity type is represented as a rectangular blocks by enclosing the entity type name. You can see here, car is an entity type which has been enclosed in a box. Okay, and attributes are enclosed in ovals. So these are all attributes of the car. They are all enclosed in ovals and are attached to their entity type by straight lines. So you can see state, number, vehicle ID, all this year, class, make, registration and vehicle ID, model, make, year. All these are main attributes. They are attached to the entity type by straight lines. Well, composite attributes are enclosed or attached to their component attributes by straight lines, and multi-valued attributes are displayed in double ovals. So color, the car may have 1 to 3 different colors. Okay. Excuse me. An entity type usually has one or more attributes whose value are distinct for each individual entity in the entity set. So each entity type will have a collection of entities stored in the entity set. So such an attribute is called as key attributes. a key attribute, and its value can be used to identify each entity uniquely. For example, name attribute of the company entity type, because no two companies are allowed to have the same name. So for the person entity type, a typical key attribute is his social security number. So in ER diagram, uh, in the ER diagrammatic notation, each key attribute has its name underlined. You can see here, we underline it inside the oval. So if it's a key attribute, we underline it using a underline. So some entity types have more than one key attributes. So car is having more than uh, one key attribute, that is vehicle ID and registration attributes. Okay. So the registration is an example of a composite key formed from two simple component attributes, that is state and number, neither of which is a key on its own. So an entity type may also have no key, in which case it is called as a weak entity type. Okay. Okay. So in the previous slides, we show three car entity instances in the entity set for car. So same name car used to refer to both the entity type and the entity set. So each entity set is the current state of the entities of that type that are stored in the databases. So we see the initial design of entity types for the company database schema. So based on the requirements, we can identify four initial entity types in the company database, that is department, project, employee, and student. So an entity type department, please refer to this diagram. So an entity type department with attributes such as name, number, manager, manager start date, and location. So here location is the only one with multi-valued attributes. So we can specify that both name and number are separate key attributes, because each was specified to be unique. So name and number. So an entity type project with attributes such as name, number, location, and control department. So both name and number are key attributes here. Name and number are key attributes. So an entity type employee with attributes. So we have many attributes. Name we have, social security number, sex, salary, supervisor, who is the supervisor of that employee, department, address, birth date, etc. So both name and address may be name and address, may be composite attributes. However, this was not specified in the requirements. Okay. So we must go back to the users to see if any of them will refer to the individual components of name, first name, middle. So name, you have first name, middle initial, last name. So an entity type dependent with attributes, the last one here you can see. The attributes such as its employee, dependent name, sex or gender, what you say, birth date, and relationship. Okay. So whenever uh, an attribute of one entity type refers to another entity type, some relationship exists. So some aspects in the requirements will be represented as relationships. For example, the attributes of manager of a department refers to an employee who manages who manages the department. The attribute controlling department of project refers to, you can see it in the this slide itself. Okay, so the attribute controlling department of project refers to the department that controls the project, and the attribute supervisor in the employee table here. So supervisor of employee refers to another employee, the one who supervises this employee. Okay, the attribute department of employee, that is this, refers to the department for which the employee works, and so on. So in the ER model, these references should be represented as attributes but as relationships. Okay. So the ER model has three main concepts: entities, attributes, relationships. So a relationship relates two or more distinct entities with a specific meaning. For example, here the employee John Smith, he works on the product X project, or employee Franklin manages the research department. Relationships of the same entity type are grouped or typed into a same relationship type. For example, the works on relation type, in which the employee and projects, the employees and projects participate, or the manages the relationship type in which employees and departments participate. The degree of relationship type is the number of participating entity types. So both manages and works on are binary relationships, means two relationships. Okay. So just I'll explain you this. Uh, Sorry. Yeah. Yeah. Okay. I think we have some problem with the computer here. Okay. Fine. Well, so a relationship type, you can say capital R, amongst n entity types. So a relationship type capital R among n entity types, that is E1 comma E2 up to, you can say, En, defines a set of associations or a relationship set among entities from these entity types. Okay, so mathematically the relationship set R, okay, the set R is a set of relationship instances Ri, small ri, small ri, okay, where each ri associates n individual entities, that is entities E1 comma E2 up to En, right? And each entity Ej in Ri is a member of entity set Ej one less than or equal to j less than or equal to n. So I just wanted to uh, you know give you the mathematical relationship here. So informally, each relationship instance Ri in, that is small ri in capital R, that is relationship type, is an association of entities where association includes exactly one entity for each participating entity type. Now, best is here you consider an example here of a relationship. Consider relationship type works on, works for, it's a works for between the two entity types, employee and department. So which associates each employee with the department for which the employee works in the corresponding entity. So here each relationship instance in the relationship set works for associates one employee. So you can see is associating with one employee. Okay. And one department entity. So E1 R1 E1 R1 D1. So in ER diagram, relationship types and types are displayed as diamond shaped boxes which are connected by straight lines to the rectangular boxes representing the entity types. So the degree of relationship type is the number of participating entity types. Hence, work for relationship is of degree 2 here. Okay. So a relationship type of degree 2 is called binary, and 1 it is called as, and 3. 1 degree and 1 of degree 3. 1 of degree 3 is called ternary. Excuse me. So here it is relationship instances of M is to N works on relationship between the employee and the project. It's an example. Okay. Well, uh, today we would like to wind up with this session. Further, we will tomorrow see the next slides, that is relationship type and relationship set. Thank you.